Have you ever wondered why prime numbers are so important? Let's delve into the world of these mathematical marvels. Prime numbers are a unique breed of numbers that are only divisible by 1 and themselves. This solitary characteristic set them apart, making them the unsung heroes of the numerical realm. These primes are the building blocks of all whole numbers. Think of them as the atoms of arithmetic, the fundamental elements from which all other numbers are constructed. And just as the universe teems with infinite stars, our number line is studded with an endless array of primes. Intriguingly though, as we venture further into the vast numerical landscape, primes begin to appear less frequently, like distant galaxies receding into the far reaches of the cosmos. So, these unique characteristics make prime numbers quite fascinating. But why should we care about them? Prime numbers are not just mathematical curiosities, they have a crucial role in our daily lives, especially in modern computer cryptography. Now you may be wondering, what exactly is cryptography? Well, it's the practice of securing communication in the presence of adversaries. And it's everywhere, from the secure websites you visit, to your credit card transactions, even to your private messages on social media. So, where do prime numbers fit in all this? The answer lies in their unique properties. See, prime numbers are those that can only be divided evenly by 1 and themselves. This makes them a key player in the world of cryptography, particularly in a method known as public key cryptography. In public key cryptography, two large prime numbers are multiplied together to create a public key. This key is then used to encrypt data. The original prime numbers, however, form the private key and are kept secret. This private key is used to decrypt the data. The beauty and security of this system lies in the fact that it's relatively easy to multiply two large prime numbers together, but incredibly difficult to do the reverse. That is, given a large number, it's extraordinarily hard to factor it back into its prime components. This process, known as prime factorization, is so computationally intensive that even with the most powerful computers today, it would take an absurd amount of time to crack. And that's where the magic of prime numbers comes into play in cryptography. Their special properties make it easy to encrypt information, but incredibly hard to decrypt without the right key. This asymmetry is what keeps your online transactions secure. So every time you make an online transaction, you're actually relying on the power of prime numbers to keep your information safe. But there's a potential threat to this encryption method. You see, the security of modern encryption hinges on one key aspect: the time it takes to factorize large numbers back into primes. It's a complex task that even the most powerful computers can take years, if not decades, to solve. This difficulty is what keeps our sensitive information safe, wrapped up in a mathematical puzzle that's too time-consuming to unravel. However, what if someone discovers a quicker way to factorize these large numbers? What if a breakthrough in technology or mathematics provides a shortcut, a fast track to solving this prime number conundrum? That's where the threat lies. Imagine, for a moment, a scenario where a rogue mathematician or a nefarious computer whiz, armed with a quicker method of prime factorization, decides to flex their computational muscles. They could theoretically break the encryption codes that protect our bank transactions, our personal communications, and even national security information. This isn't just a theoretical concern either. Quantum computers, machines that operate on the principles of quantum mechanics, are on the horizon. They promise to perform calculations at speeds that are inconceivable by today's standards. If they become a reality, our current encryption methods, based on the complexity of prime factorization, could become as easy to crack as a child's secret diary. This potential threat isn't lost on the world's mathematicians and computer scientists. They're well aware that a faster method of prime factorization could spell the end of encryption as we know it. It's like a ticking time bomb waiting for the moment when someone figures out how to cut the right wire. So, the race is on to find new encryption methods, just in case someone cracks the prime number code. So, why should we care about prime numbers? You might ask. Well, let's take a moment to reflect on what we've discussed so far. Prime numbers, those unique quantities that are only divisible by one and themselves, are not just curiosities of the mathematical realm. They are, in fact, the backbone of modern cryptography. They are the unsung heroes that keep our digital world ticking and our private information secure. Their unique properties, their indivisibility, make them the perfect tool for creating secure encryption systems. These systems, in turn, keep our digital transactions, our personal messages, and even our national security safe from prying eyes. The complexity of breaking down large numbers back into primas is what makes these encryption systems so robust. So, while prime numbers may seem like an abstract concept, they are fundamentally woven into the fabric of our daily lives. They are the silent guardians of the digital world, the secret sentinels of our online safety. So, the next time you use your credit card online, remember, it's prime numbers that are keeping your information safe.